This is John Black, Super Chemist. This is just a disclaimer to let you know that this video is not intended to be imitated. No parts of it should not be copied or done by you or anybody. It's just for educational and maybe entertainment purposes to watch. That's it. I don't condone anyone repeating anything in the video. Look, I want you to realize something. I mean, even if YouTube didn't say anything about putting disclaimers on, this is, I would still put this in the video. This is a tin can. It's an old rusty tin freaking can. It's got seams on the top, seams on the bottom. It can get a leak, you know what I mean? I just tapped it with a freaking utility blade and it put a hole in it. I'd epoxy it. And if you noticed in the video, I only distilled water. Okay, if you have anything explosive in here, you know what I mean, and you get a leak, chances of, catching on fire is pretty good, man. It could blow up. Could, you know what I mean? I mean, this is the most unsafe thing in the world to do. You know, I mean, you can make a steel out of, copper or whatever and have it nice or whatever. This is garbage, okay? And it's nice for novelty, but it's not, this is not safe to be making this and using it unless you're going to use it to distill water. So I do not recommend anyone make this. I have to distill something. I don't want it to screw up my glass. I use this kind of thing for like calcinations or whatever. Anything that leaks, any kind of leak that's going all out on your flame, all out on your heat, all on your lungs, you know what I mean? Very unsafe. Here to make a steel. Now this, you can't use this for everything, you know what I mean? Mostly solvents. This isn't for acids, or you know what I mean, using a metal can to start with. This is just basically like an old acetone can, but I ripped off the label and you can see how old it is. I sanded that down, and I'm basically up. My car's been broke down since Christmas, so I'm just scavenging around the house. This is what I found. See how it has the threads on the one side, and on the other side it has the barbed, kind of like you have on your glass, or condenser or something. You put a hose on there. So that's a ½ inch right there, those threads, right? So what I did was I went through each one of these, right? 3/16 and, 1/4 inch, 5/16, 3/8, and then I made it up to a ½ inch. And I kept consecutively making this hole right here. So now it's the same exact size as this. I'm just going to force that in just a little bit. I got my thing, my wrench. I'll leave a little space there so I can get my JB weld in there. This is what else I found. Why I've been putting this off, because I couldn't find it. It's called JB weld. It's two things that mix together. It's some kind of epoxy thing. But they have different kinds. It tells you down at the bottom what it's for, like metal, glass, fiberglass. This, and then on the back, you look at the bottom there. It says that it goes up to temperatures of 230 Fahrenheit. That's a pretty good bit. I don't know if you can see it with me moving around. And basically JB weld that right along here, right? So I figure the cap is airtight. I'll get back to you after, because you got to mix these two together, and then they harden. But before they harden, you hurry up and put it on your seam, your hole, your crease there, and weld that up basically. I lost the footage, but first, okay, remember this is the bottom part, right? I got one of these. This is for a thermometer. You would put your thermometer through this hole here, see? And then you got your ground glass joint, right? Basically, I'm just turning it upside down, right? And I'm going to jam it in to this until it looks like that. I want you to look at this without the gasket. Here's the bottom, right? Here's the top. See how it actually goes inside that glass? It's a perfect fit, like, you know what I mean? So as long as it stays like that, none of your gas should touch the gasket, you know what I mean, or very little. Plus, this is very flexible because it's just this gasket holding this on. See what I mean? Very flexible. Look at that. I can take it off easily or whatever, you know what I mean? You can see it's starting to get water up in there. Not quite up to the top. Oh, it might be a little too high. It's been distilling here for a little bit. You see it's got a little bit in the pot. No leaks or anything. It's holding up. It's been going for a while now. Now, if I didn't have all this glass, I could take this copper pipe and bend it right here so it made this shape, and then put it in the hole there, right? Make it the hole just slightly bigger than this pipe, so I have to almost smash it in there so it's nice and snug, and then add epoxy the pipe to the copper pipe to this instead of that attachment. And then I would wrap plastic around this, right, all the way around it, and connect the plastic tubings, because that's what I'd wrap around here, plastic tubing. I would have an end sticking out on each side, and I can connect that to my water pump. And so it'd be a water-cooled condenser. This needs to be cooled down, okay? And there's an easy way to do it. You see my tubes coming off of my condenser, right? Here's a real condenser. Got your import and output for the water, right? Now I just take the tube, I put it into the port, and then this goes into a water pump, right? So that way we can pump water through here, and then the bottom one goes out and back to the well to replenish the water for the water pump, right? So all I'm using to connect my pump up to this is this hose here, right? Just like on this condenser, my pump has a barbed thing like that, and I just shove the tube right in there, right? That's all it is. Take the tubing, even enough, you can stretch it out to this underneath your pump. So this is my extra tubing that goes to my pump, right? Then I come back to this part, right? I don't have enough, so I'm going to move it over. and then you just wrap it around. You can wrap it like that if you want to be, you know, generic about it. Or, I've actually made one of these. It takes a lot of tubing to do this, though. Or you can wrap it like that, all the way down. See how it's literally touching. See what I'm doing? Just wrapping it around all the way down. And then you'll have ice cold water going all the way around this, around the entire length. You know, you can have it 2-3 feet if you want. So anyways, I did end up putting the can on. You can see I just left, this is the same can, I left that port on there, and I put this right over the port and welded it to the port and the can. And then, as you can see, I got plastic. Here's my in. You can see I wrapped it around and I put tape on it. Actually, 2 different kinds of tape. This right here, this is just because I didn't have a long enough tubing to be the same tube. So this is actually a bigger piece than the rest of it. So it wasn't going around right. It was kinking up. So I had to leave it out like that. But I do have, you know, here's the can. So I have condenser from here, right? Here's my whatever, in or out, all the way down to here. And then it comes out here. So that's what it would look like. You know, and it is with a water-cooled condenser. But remember, this is a novelty type thing, you know what I mean? Even in the video, I only distilled water with it. You know what I'm saying? Always remember, science is great.